Hello, in this video I'm going to be going over complex reactions and reaction mechanisms. So a complex reaction is the summary of many elementary steps or pieces of a reaction, whereas a reaction mechanism is showing the procedure, which reaction comes first, which comes second, which comes next. So in this first problem it says, what is the net reaction? What we are looking for is the overall summary reaction. So similar to Hess's law, we have to cross out the entity that's found on the reactant side and on the product side. So looking at this, there's multiple ways. You could cross them out here, or it might be easier to visualize it by writing all of my reactants. So I got A plus B plus C plus D plus X plus B. And then I'm going to write all my products, C plus X plus Z plus D. Alright, anything found on both sides looks like C is found on both sides of the arrow, so I'm going to cross that out. X is found on both sides of the arrow, and D is found on both sides of the arrow. So my overall reaction is A plus B reacts to form Z. You could also write it as A plus 2B reacts to form Z. Next question is, what are the intermediate complexes? So in this case, an intermediate is something that is produced in one elementary step and consumed in another elementary step. So C would be an example of something that's being produced by one elementary step and then is consumed in the second. So C is definitely an intermediate. And it's also, an intermediate is going to be something that is one that you crossed out. So one of these three, either C, D, X, or multiple of them. So looking at X, we have X is produced by one elementary step and then it's consumed by another. So X would also be an intermediate complex. But then the third one, D. D is, it's not produced anywhere except for that final product. It's simply added as a reactant, and then it comes out as a product of another elementary step. So in that case, since it's not produced by an elementary step, it can't be an intermediate, so it's going to be a catalyst. So it's not consumed in this overall reaction. Alright, moving on. Here's an example. We're given a bunch of data. Looks like this. This is a potential energy diagram. Instead of just having one curve, here we have three curves because there are three elementary steps in this, each with their own activation energy. It says, what is the delta H? Nothing changed here. That's the difference in energy of the reactants and the products. So I'm going to do products minus reactants to find my delta H. Here it's 200 kJ minus 260 kJ. That's going to equal negative 60 kilojoules, which is exothermic, which is correct because we're starting with more energy than what we're ending with. So the difference is being released. Negative 60 kJ is our delta H. Which is the rate determining step in Y? Alright, rate determining step, what is that? That is the step that basically determines how fast a reaction can go. The higher the activation energy, the slower that step. And the slower the step, the slowest step basically determines how fast that overall reaction can go. It's kind of like having a relay team doing a 400 in track. The person that is slowest, they are going to basically determine how fast that group can go. Same thing with this. The slowest step is going to be the rate determining step. Determines how fast that overall reaction can go. And the slowest step is the one with the highest activation energy. Why is that? It's kind of like riding a bicycle up a very, very steep hill or riding a bicycle up a small little hill. Which one is going to take longer? The one that's a high hill. Same thing with a chemical reaction. The one that's going to take longer is the higher activation energy. So step 1 is the rate determining step because it has the highest activation energy, therefore it takes the longest. It is the slowest. reaction. Therefore, it determines the rate. What is the activation energy of the rate determining step? So this is just a potential energy question. We have the activation energies right here. We're starting at 260, ending at 440. What is the activation energy? 440 minus 260. If you don't know how to do that in your head, that's totally okay. In that case, you just take a calculator that you always bring to class anyways. Got it. Why not use it? Alright, 180 kilojoules is the activation energy of the rate determining step. And that's just a few examples on how to do mechanism problems. That is that.